and structural engineering industry. Yeah, so overall, just find interesting problems and think about like interesting interactions, and also ask yourself like why you want to build this model. Is it just because, oh, I have a tool and I have a hammer and I'm seeking a nail? So the first paper is called House Scan. This is a intern work, and we also work with Professor Yasu from Simon Fraser University. So this paper is submitted to ECCV this year, and we're still waiting for author notification. Yeah, and this work is basically trying to solve a problem where when architects are brainstorming kind of room layout designs with their customers, architects usually start with this bubble diagram, right? And then they have to go back and forth discussing with their customers what are their needs, like this bubble diagram, if it makes sense to satisfy their functionality. And then architects will go back and then come up with this layouts, right? And then customer will look at the layout and point out some of the things they do not like as much, and then architect has to go back. Right. So we want to automate this process, right? We want to have this process of generating multiple layouts that satisfy this bubble diagram, so that this is kind of a tool where we can generate a bunch of solutions. So even with this the same bubble diagram, we can create a bunch of different layouts that satisfy this bubble diagram, right? And then maybe the customer can choose from one of this and then do some tweaking. Yeah, so this is basically this research. And yeah, and another paper is learning to simulate and design for structural engineering. This paper recently got accepted to ICML 2020. So this work is actually, I think it's the first paper that applies like deep graph neural networks on structural engineering. So we model this building geometry with a structural graph, and then we want to train an optimization model for this site design. So site design is basically, we have this building geometry, the skeleton of the building, right? And we want to output what are cross-section types for each bars, like columns or beams, right? And yeah, and the optimization involves some of the structural analysis outputs, right? We want to make sure that this size design satisfies some like building code constraints, for example, like storage drift ratio, limit, etc. So we also want to train a surrogate model for structural analysis. Here's the simulation, structural analysis. And we can have this trained model to output predictive structural analysis results, and then we can compute our objectives and constraints. So this is an end-to-end learning pipeline. So we can first pre-train this surrogate model, and then we train the optimization model. Yeah. So some of I can show this our generated designs, so which is very interesting. Yes, so we train the optimization model for different scenarios, and then we can have this here. The harsh constraint is we have a very strict drift ratio limit, while the moderate constraint is we have a higher, which is looser drift ratio limit. And here the zero weight and low weight and high weight are the the weight of the cost loss. Yeah. So yeah, we can see that when cost is not in our consideration, we get really like complex design. And yeah, but if we add the cost objective, increase the weight of cost objective, and we get like better designs. So if we take a look at the the high weight solution, right? For moderate constraints, we can see that the model generates it has these micro decisions on individual bars, which doesn't look natural to human designs. But for the harsh constraint, we see that this looks more like a human design, right? So we actually show this design to structural engineers to get their feedback, and they do see some of these insights. So for example, we see the model tends to use stronger and thicker columns at the bottom of the building, which we didn't specify it during learning, right? The model actually learns because of the objective we give. Yes. So this is the result for optimization model. Our surrogate model also performs pretty well. So we reach a 98% accuracy, and compared to, we use Autodesk robot structural analysis for the structural analysis software, and compared to that software, yeah, our model is like very fast. Yeah, it's 300 times faster. So our model only takes like 43 milliseconds. Yeah. So what what can we get from these two trained models? So for surrogate model, right, we have a fast approximation of the structural analysis, and this can be used to provide instant feedback for example, like architects when they're in like early design phase, right? We can already have this plugin instead of having a structural engineer or structural analysis software at the site, and which is very slow and laborious. And also, when we're doing some kind of simulation-based optimization, we have in each iteration we need to call the structural analysis software, right, which is very time-consuming. So we can actually use this surrogate model to replace the traditional software. And for the optimization model, we later show its performance comparing to genetic algorithm. So the solution can actually serve as a seed for genetic algorithm, and that actually speeds up the optimization process like 8 times. So yeah, so I think this is a very interesting research work, and this is actually the first paper that applies graph neural network to structural engineering domain. And I do see there's a need to raise this interest from deep learning community, and then they can jump in and create more interesting research work on this direction.
According to you, what are the potential challenges faced by building industry to adopt AI applications?
Yeah, right now in Autodesk, we deal with a bunch of customers, and there are a lot of challenges we face when we're trying to collaborate with industries, because not, I think it is still a very, not many industry has adopted this AI application, right? I know it's because changing the same workflow that exists for decades is very hard, right? And you have to invest a lot of money and time, for example, like collecting data. So one issue is that most of the time we don't have enough data, right? So imagine a company who has run for like 10 years, and each year they provide 50 projects, right? Either design or construction projects, right? They have basically 500, but 500 is usually not enough for training like deep learning models. So usually we'll have 10K or 100K data. So yeah, this is the challenge there. So it is very hard for one company to get enough data.